deriving speed, distance, angles, and heading. A 2D implementation is realized with a 3A, 3M sensor set, while a 3D implementation is realized with a 3A, 3M, 3G sensor set. This particular video clip demonstrates a 2D trajectory utilizing the 6-axis sensor worn on the shoe.
So this one is very short. So every stride which is shown on this video has been recorded from real experiments. The algorithm estimates the best 2D trajectory from the sensor signals, and it computes a real-time dynamic orientation of the foot, and is then able to compute the trajectory. So the value for this feature is in sports, of course, but also in health and rehabilitation applications.
Lastly, I'd like to cover full body motion capture. The algorithm combines a mechanical body model with the data from a body area network of either 6 or 9-axis sensors, tracking the motion of our actor. In the video, our actor is wearing 7 6-axis sensors, 2 on each arm, 1 on the torso, and 1 on each foot. You will see the avatar mimic the motions of our actor in the background.
So for the first green avatar, the sensors are 3A, 3M, therefore leading to normally only slow motion estimates. However, the second part of the video with the wired avatar is showing how much a global sensor fusion approach on the left part of the screen improves the avatar posture estimate, even if 3A transfer in an aided dynamic case. Fast motion can also be obtained by AGM full-blown sensors, just as shown in the last cut of the video, with a comparison of an arm motion with an optical system.
So that concludes the tour of the motion features. At this point, I will turn the presentation back over to Bruno to cover the use cases.
Thank you. So in this third part, we will go through use cases where several motion features are mixed in order to achieve a product's full requirements. So the first one is sports. So this example is dedicated to a swimmer product design. So the first goal for motion here is to count laps. We have not up to now presented any detection motion feature in the database, or it was hidden and not highlighted. This one is quite simple to understand, probably less to implement. In this design, the laps are detected at every U-turn thanks to a 3M sensor. No calibration, no specific orientation of the sensor on the body is required to keep it simple for the end user. We also delivered an MP3 player at the same time in the product. Power management and optimized footprint is taken into account by Movea, and this product is shipping. 3A will add some classification features, strokes counting. In this second use case, we take advantage of the previously described Air MotionIC. We add gesture recognition features that were demonstrated and the estimates for angles. So in the end, the global motion service relies both in the remote, hardware and firmware, and in the set-top box or TV as software. So the next slide introduces the video. So as we will keep it in the portrait window, I'll launch the video now. So this video shows a mix of different motion features applied to media browsing. We try not to overwhelm the user into much technology, as our experience in research and economics-driven studies showed that simple is beautiful. So please note the intuitiveness of gesture-based interaction. At the top right subscreen, you can see the user's hand and screen. Each gesture is followed by an orange icon, briefly shown on the bottom left of the screen, so that the user gets immediate feedback. The main screen is a capture of what is shown on the media player screen. We have both simple and more complex gesture recognition with swipes to get left, right, up and down navigation through lists, We also have letter recognition, so that the user is able to navigate through his media list, just drawing a letter in the air. We also added a roll gesture to permit browsing through a long list with a continuous selectable speed, from slow to fast capabilities. An up and down control of the volume helps control the sound level very intuitively. For easy navigation, you also need a kind of enter key, which is here a check gesture, a stop key, which is here in the shape of an alpha letter, and a back or escape gesture. You also need a play and stop key. You just kind of shake the remote to do this. And so the user will navigate through his library thanks to gesture, music, pictures, video. Go to the next. So let's go to the third and last use case. So this last third use case uses the full-blown orientation feature. We bring it with the 3A, 3M, 3G for dynamic motion. 3A, 3M is also a good solution. It reduces cost and power needs, but would not allow fast motion, nor estimate the acceleration experienced by the object or limb in this use case. On top of the access to this orientation motion feature, at the hardware level, we bring wireless network capabilities for several sensors. This is a must-have for this kind of use case. Several sensors can be worn on the body. You need them small and wireless. This wireless network is built on top of a proprietary radio protocol to allow low latency, low power consumption, and flexibility in the network. So the next slide introduced the video. The short video will show how our customers can take advantage of this feature. So both range of motion and biofeedback exercises are built on top of the angle feature. This video shows rehabilitation software that accurately quantifies severity of a given impairment by measuring the range of motion, the fluidity of movement, the speed of execution, etc. And it reports patient progress through intuitive biofeedback video games like exercises. So in this story of this product, what is typical for Movea, what we like, is that our customer could rely on the development kit we delivered and could focus on its expertise, which is about joint assessment and rehabilitation at the physicist's office. So before we conclude for this webcast, we wanted to explain why we believe that we are perfectly fitted to develop new motion features. So our process is quite simple. Requirements first, motion requirements. We can help the customer or partner to write down these requirements. And then the hardware and software tools, motion pods and motion logs here. We have developed them and we own them. Can then be used by our teams to acquire scenario representative signals and usually build a motion signal database. So these proprietary tools enables us to get motion signals fast and easy in many situations. Then the data flow design stage. The design stage will benefit from the software internal tools we develop to design the signal processing data flow, and a performance prevision can then be made. Performance can be predicted for several types of sensor combos. This therefore helps our customer to choose the best cost to performance ratio. And then the last two stages, the motion feature is then developed together with the hardware and global project architecture. The prototypes are then qualified. So this is a quick view of our Movea Lab software. It helps the data processing engineer to design the data flow. It's a flowchart diagram where you can drag and drop motion feature boxes. You link them from one to the other very easily. So the idea behind this is to rely on a growing database of motion boxes to get the data flow quickly done. Of course, this data flow system is connected to our hardware and sensors. So up to now, we have developed a smart motion feature database. It's already quite rich, so that we can build the product data flow in reduced time. We carry on building this motion feature library. We maintain a high investment in our R&D through partnership with top-of-the-game labs. And we own or are licensed on a more than 65 patent family portfolio, which is still growing. So here are some testimonies from our customers or partners. So I like the one from Patrick Garrigue. Movea Smart Motion Feature solution was so easy to use, it reduced our time to market by over 18 months. So now it's time to conclude. And Tim, this is where you take the mic.
Well, first, thank you for your attendance today. In conclusion, Smart Motion by Movea provides our customers access to an extensive patent portfolio and motion-enabled product know-how, bridging the complexity gap and reducing time to market with flexible partnerships ranging from IP licensing to full product design. Once again, thank you.
Well, thanks a lot, Bruno and Tim and Jean-Christophe. And it's time for our Q&A. That was an excellent presentation. A number of people commented on really liking the videos and how much that helped them understand just how these features work. To kick off the question and answer, everybody in the audience can submit questions, or anybody in the audience can submit questions via the chat panel bottom left of your screen. But I'd like to kick it back to Jean-Christophe just for a minute. And JC, have you got any burning questions for these guys that you would like them to answer?
Well, I'm impressed by the tools developed by Movea and how it is easier to integrate this motion sensing into the activity. But from the customer of Movea point of view, well, what is the normal process of working with Movea? That means, is it months of work? Is it weeks? Or how is it working to be a customer of Movea?
Okay, so in the process we showed in this inside the MotionIC factory, I think really the time in which we develop the motion features is really dependent on what motion features required. For some cases, we already have turnkey solutions, so it's just a matter of qualifying the requirements from the customers, and then we can give them the solution in no time. When it comes to more specific questions, when we have to mix motion features that we already have, we can demonstrate motion features in a short delay, like weeks. When it comes to developing a brand new motion feature, it can take maybe 2 to 3 months. So it really depends on the path that we have to go. So from turnkey solution, then there is no delay, to up to new developments that could lead us to very specific development.
Excellent, excellent. We've got a number of questions coming in from the audience at this point, so I'd like to go to some of those and throw them to you, Bruno and Tim. I leave it to you to decide who is best to answer these. One of the first questions is about just how agnostic are these, in fact, and so can these sensors work with any can your software work with any sensor on the market, and is there any differentiation?
So this is Tim. I'll take that question. As far as being sensor agnostic, we definitely are a sensor agnostic company.